Hello, everyone, and welcome to Migrating Content Distribution to Amazon CloudFront Best Practices. My name is Ted Middleton. I lead the Solutions Architecture team for Edge Services, and with me today is Jabril Tuzi, who's also a Solution Architect for Edge Services. Over the next 30 minutes or so, Jabril and I are going to review some of the considerations and specific use cases we often see when working with customers migrating to CloudFront. I'll start off with a brief overview and a refresher of what CloudFront is and some of the other AWS Edge networking building blocks that you can use. We'll talk about some considerations about why you would want to migrate your web delivery and applications to Amazon CloudFront, some of the common challenges and maybe even objections that we often hear customers suggest. We'll talk a little bit about some best practices and guidelines for managing the migration process. And then Jabril's going to jump in with some specific use cases and feature scenarios that we often come across, and we'll wrap it up with a demo that Jabril's put together on image resizing and optimization using different formats for different devices at the edge using CloudFront, CloudFront Functions, and Lambda at Edge. So first off, what is CloudFront? So CloudFront's a leading global CDN infrastructure. It operates over 230 different points of presence around the world. It combines caching, network, and protocol optimizations and a variety of different features to create a really flexible and programmable edge-deployed infrastructure to move content and application logic closer to your end users to improve performance, reliability, scalability, and security. Some of the other services that are also in the Edge networking portfolio that complement CloudFront are services like Route 53, which is a DNS service that can do advanced load balancing and traffic management. Global Accelerator, which is also a performance optimization service that can take a regionalized deployment and broadcast it using a globally available set of Anycast IPs, and then has its own request routing and traffic direction, including its own health checking mechanisms to do load balancing, application failover. Then security services like AWS Shield, which is at-scale DDoS detection and mitigation. AWS Web Application Firewall, or WAF, which does layer 7 inspection, and you can do custom rules and includes things like bot mitigation. And then lastly, AWS Firewall Manager, which is a policy engine that allows you to centrally configure firewall rules and apply established policies even to new infrastructure instances as you bring them up. So what are some of the reasons why you'd consider migrating to web delivery to CloudFront? One is cost. So there's definitely some advantages that CloudFront brings to the cost equation. First of all, it's a very competitive service, offers several different pricing models from public to private pricing if you're willing to commit to certain usage thresholds. It also zero rates egress traffic coming out of AWS regional services. So any application that you put CloudFront in front of now rates that outbound traffic at CloudFront's rates, which are typically offered at a discount compared to lots of the AWS regional services. Security is another advantage. So all AWS services are designed with security in mind as job zero. CloudFront is no exception and goes through rigorous security reviews, both during the design, the implementation, and during operational phases. It also adds security in terms of being a distributed, diffuse infrastructure that moves a potential attack surface closer to the edge and away from your origin infrastructure and applications. And it also has tight integration with the security features I mentioned, as well as a number of different security features, some of which Jabril will touch on later, that allow you to protect content and applications. Performance is an obvious one for any CDN. Obviously, the big advantage is moving those transactions, things like connection termination closer to the end user, improving latency, reducing number of round trips, improving throughput, and localizing content and processing where it's needed. And lastly, integration. So you're using something that's part of the AWS overall portfolio. The developer experience is very consistent. You have full APIs, console, CLI, and integrations with DevOps and automation tools like CloudFormation and others. Some of the common challenges that we hear are things like you might be dependent on a particular feature with another provider. You're kind of locked in. Maybe you're dependent on them for pro serve assistance in implementation. You might have complex account structures and need to migrate many different properties. Obviously, things like cost and resources are also often questions and issues. Some of the ways that we address this is CloudFront is an increasingly rich platform with dozens of new features added every year, and it's constantly invested in and improved upon. We also have CloudFront Functions, which was introduced this year in 2021, and Lambda at Edge, which both allow you to take custom application logic in a variety of different languages and move those to the edge for faster processing at scale. And Jabril will touch on some of those. We have a number of different support offerings from assistance that people like Jabril and I provide when you're evaluating a service like CloudFront. We also have extensive professional services offerings, some specifically to assist with migration. And then we have obviously enterprise and other support options that make other resources available. But the other thing is that our services are designed to be self-service, that nothing locks you into requiring additional services from AWS. As far as migration processes and best practices, there's 3 phases we commonly think through when working with customers on a migration. The first is preparation. So this is important in understanding what are your objectives and your success criteria and how are you going to measure those. You want to document your current state, including things like your origin and CDN configurations if you already have them. Understand your different content and usage profiles and how those profiles are affected by usage or change patterns, how often content is updated, things like that. And then you want to collect baselines on your performance and reliability so that you can understand kind of where you're coming from and where you end up. This is also the phase where you want to conduct potential proof of concept or do experimentation, and that's where people like myself and Jabril can work with you to try different things, explore the feature set, and try to implement your application using CloudFront. During the migration phase, obviously this is when you want to use techniques like DNS or other load balancers or traffic management mechanisms to plan out a shift in how you're going to move traffic from one environment to the other, or how you're going to introduce maybe CloudFront as an additional CDN in a multi-CDN environment. And this is where you also set up your kind of before and after performance testing and make sure that you've got harnesses and things like that to look at what's happening during the migration. And then lastly, during the maintenance phase, this is where you'll be observing the sustained results, evaluating hopefully additional opportunities to optimize your configurations, maybe implement additional automation or scaling techniques. And this is where you also want to kind of make sure you stay in touch with the product, explore ways to fully exploit some of the native features and options that you might not have considered up front during the migration, and stay in sync with product updates and evolution as they occur. And there's a link at the bottom of this slide that gives you some information. There's a blog series that talks about migration best practices and techniques. And with that, I'm going to hand it over to Jabril to run you through a couple of specific features and configuration options and get to the demo.
Thank you, Ted. As you mentioned, customers leverage CDN to improve performance, security, and to lower cost. CDN use cases include website delivery, dynamic content and API acceleration, live or on-demand video streaming. These use cases generally require some features. In the coming slide, we will review some of them and how you can implement them using Amazon CloudFront. The first use case we generally see from customers is delivering static and dynamic content using the CDN. You can use CloudFront to speed up delivery of both static and dynamic content. CloudFront provides features like cache policies that provide a granular control to configure headers, query strings, and cookies that you can use to compute the cache key. We also provide origin request policies that provide a granular control to configure headers, query strings, and cookies that can be forwarded to your origin without impacting caching. Note that these policies can be associated to cache behaviors, and you can reuse them in different CloudFront distributions. Another feature we see from customers is access control. we have customers who want, for example, to serve private content. With Amazon CloudFront, you can use sign URLs or sign cookies to serve some content that are private to your users. You can also use CloudFront functions, which is one of our edge functions offering, to implement a sort of token authentication at the edge. At the end of this presentation, we will provide you with some links to some resources. We have some other use cases where customers want to clock their origin, meaning they want to log their origin so that only the CDN, right, only CloudFront can access that origin. If you are using Amazon S3 as origin, we provide origin access identity out of the box. If you use EC2 instances or application load balancer, you can use security groups. CloudFront provides the list of IP ranges you can use to allow access to your application only from Amazon CloudFront. We have some other users who want to implement some sort of geo-restriction. This is, they want to allow requests only from some countries or deny requests from some countries. They can use a native feature from CloudFront, which is geo-restriction, that allows you to allow or deny some countries. And other customers want to go further, right? They want to grant access based on IP addresses or block some IP addresses. For that, you can use AWS WAF, which really integrates with Amazon CloudFront to allow or deny those IP addresses or IP ranges. It is the same. You can also use CloudFront functions, which is one of our edge offering, edge computing offering, to allow or deny those IP addresses. You also provide CloudFront geo headers. For example, you can know exactly the state or the country where the request comes from, and this is generally important if you want to route users or even to block or allow from some specific state in the US or countries. Other use cases include origin failover. You can set up CloudFront with an origin for scenarios that require high availability. For this, you create an origin group with two origins, a primary and a secondary origin. If the primary origin is unavailable or returns a specific HTTP response status code that you have defined, CloudFront automatically switches to the secondary origins. Note that you can use origin failover with Lambda-H origin event, right? If you have a Lambda-H origin response or origin request, you can still use origin failover. In this case, CloudFront, the origin response origin request will be triggered twice in case of failover. We have some other customers who have requirements for reports, metrics, and logs. They currently use a CDN, or even they're not using a CDN, but they want to have some sort of metrics, logs, to have a clear view of how the application is working or how users access the application. CloudFront provides tools for reports and monitoring. A variety of reports are available for you to see usage and activities for CloudFront distributions, including billing reports, cache statistics, popular content, and top referrals. In addition, you can monitor and track CloudFront, including Lambda-H activity, directly in CloudFront console, and by using tools such as CloudTrail to track API calls, and CloudWatch. And CloudWatch provides logs and CloudWatch metrics. For logs, you have CloudFront functions and Lambda-H logs delivered to a log group. Our access logs provide a wealth of information about what is happening with your CloudFront distribution as it serves content. You can generate these logs in real time and have them delivered within 10 seconds in one of your Amazon S3 buckets or in external tools like Splunk or Datadog. Another use case we see from customers is header manipulation. This is the ability to insert, modify, delete HTTP headers in the request or in the response. These headers include true client IP, cache control, CORS, or even custom headers. You can implement this using AWS H functions, which are basically CloudFront functions, and Lambda-H. CloudFront functions is a native platform feature. It was released a couple of months ago. You can write your function in JavaScript for high scale and latency sensitive CDN customizations. Its runtime environment offers sub-millisecond startup time and can handle millions of requests per second. On the other hand, Lambda Edge, which is an extension of AWS Lambda, provides a powerful and flexible computing for complex functions and full application logic close to your end users. You write your functions in Node.js or Python, publish it in a single AWS region, generally in US East 1, and AWS automatically replicates that in other AWS regions. So if you are, for example, a user accessing your content in Europe, the Lambda Edge functions will be executed in one of our regional edge caches in Europe. Another use case is URL redirect and rewrite. This is the ability to redirect viewers to other pages based on information in the request, or rewrite all requests from one path to another. For example, redirecting users to a country-specific version of your website based on the country of origin, or to improve SEO, rewrite URLs to append index.html to the end of URLs that don't include the file name. So this basically, you can do that using platform functions or even Lambda Edge, depending on your use case. We also have another use case we generally hear from our customers, dynamic origin selections. We have customers who have a multi-region strategy, who have customers, for example, in Australia, in Europe, and in the US. They have multiple origins, and they want to serve the end users with the best latency. For this, they have origins in all those regions, and they want users in the US to be routed to the origin in the US, users in Europe to be routed to the origin in Europe. For that, you can use AWS Lambda Edge origin request function and the geolocation or the geolocation header to route all those users to a country specific, to the right origin. And we have some sample functions on our website. On that page you have on the screen, you can have, you see how to move, for example, from an Amazon S3 origin to a custom origin, if it can be an EC2 instance, ALB, or even host elsewhere. You have a sample function to transfer from an Amazon S3 bucket to another Amazon S3 bucket. So you have your S3 bucket in different origins. So with Lambda Edge, you can do this kind of dynamic origin selection. We have a page on GitHub where we have published sample codes for CloudFront functions. As I said, it was released. This feature was released 2 months ago, and allows you to run code directly in our more than 220 edge locations. You have sample functions, for example, for adding course headers, for adding the true client IP, or even to add the cache control header. You also have a sample for URL rewrite and URL redirect. In the demo we will see in a couple of minutes, we have a sample platform functions code to rewrite URL, incoming URL. We will go right now for the demo. This is basically a sample of how you can use edge functions, which are platform functions and Lambda Edge, to resize image on the fly. Resizing image on the fly is a use case we hear from many customers, and it can help you to save on data transfer out, because you deliver images that are customized for the end users. If, for example, they have a browser or a mobile device, we serve image exactly the size that is needed for that specific device or browser, unlike just saving a single image to all the different devices. So thank you for your attention.
Welcome to the last part of migrating content delivery to Amazon CloudFront session. This part is a quick demo on how you can use AWS Edge functions to resize images at the edge and optimize their format based on client devices and browser support. In the previous slide, we provide some details on AWS Edge functions, which are Lambda Edge and CloudFront functions. If you need more information, refer to Amazon CloudFront documentation. With this solution, You can customize images on the fly without having to pre-process each image manually. This will not only help with saving on data transfer out, but it will also ameliorate user experience by improving performance and delivering images customized for devices and browsers. This demo is based on a blog post written a couple of years ago, with the difference that it uses CloudFront functions instead of Lambda@H for the viewer request. You can find the link to the blog post on the results slide of this session. You also have the link on the screen. It contains a CloudFormation template you can use to easily deploy the solution. Here is the flow of the request. The CloudFront functions viewer request event function receives the request from the viewer and rewrites it based on the value of the accept header and the query string D. If the request does not contain the query string D, it uses the default dimensions to rewrite the URL. If the object is not cached at the edge locations, it forwards the request to the origin, which is an Amazon S3 bucket. The S3 bucket responds with a status code. If it is something other than 404, it forwards it to the viewer. If it is 404, it tries to fetch the original URI from the S3 bucket. If it receives, again, a 404, it's forwarded to the viewer. If it is a 200, it resizes it, returns it to the viewer, and then uploads that to the S3 bucket using the rewritten URI. This function leverages an external library named Sharp, commonly used to convert large images in common formats to smaller and web-friendly images of varying dimensions. For the sake of this demo, I've already created a CloudFront distribution in an Amazon S3 bucket, and I've configured the S3 bucket to be the origin for the CloudFront distribution. For more information, see getting started with a sample CloudFront distribution in the CloudFront documentation. You can find the link here. Let's log into the AWS Management Console and create the two functions. I have no function in this specific account. You can create a function using the console or using any SDK. I will use the CLI since I'm used to the CLI. For this, I use the create function API. For more information, refer to the CloudFront CLI documentation. This generally takes a couple of seconds to be created. That is done. If I refresh my page here in CloudFront functions, I should be able to see my function. CloudFront functions provide you with sample test events that allows you to test your function directly in the console. Here we have a viewer request, and I want to add, for example, the accept header and the query strings. If I test this, it is successfully and here we can see that there are no query string D in the request, so returning the default size and format of the image. If here, for example, I go in the inputs, I change, I add, for example, the accept header. I want to change it. Accept header, accept. I add image web P. I add it. And for the query strings, I add D, for example, and I want the object to be 100 times 100. When I test it, here is what CloudFront requires to your S3 bucket. When you test your CloudFront functions, the next step is to publish it. You click on publish. It takes a couple of seconds. And when it is published, you can associate it to a CloudFront distribution. For our case, when you click on distribution, you have all distributions in your account. You can use, we choose that. It is on the viewer request, and we choose the behavior. We have a single behavior for that specific distribution. We add the association, yes, add, and this will be associated to that specific behavior. You can go and create the Lambda@H function. I will do the same, just that we will be using the CloudFront API or the Lambda API. As we said in the previous part, Lambda@H is an extension of AWS Lambda. So CD. So I have my Lambda@H code here and all the dependency. The first thing is to zip the file. Let's zip that in net302, for example, .zip. So when we zip the file, we go ahead and create the function. Now, the difference is that this create function is a Lambda API. It is not a CloudFront API like for the CloudFront functions. For more information on this, again, refer to our public documentation. the Lambda Edge function has successfully been created. If we go in the Lambda function in US East 1, it is very important to mention that the Lambda Edge function must be created in US East 1 region. So if we go in US East 1 region, we see that the function is there. What we need to do now is to publish that, right? We need to deploy it to Lambda Edge. For that, we go in Actions, deploy to Lambda Edge. Normally, you have all the CloudFront distribution in your account list here. We want to add it to this CloudFront distribution. Here also, you have all the behaviors. We have a single behavior to that CloudFront distribution. We want it on the origin response. It is when the request leaves the S3 bucket and comes back to CloudFront that this function is executed. You acknowledge that and we deploy to CloudFront. So now that we have create our Lambda Edge function and publish it, and create also our CloudFront distribution, our CloudFront functions and publish it, let's go to the CloudFront distribution, choose the behavior. We will see that we have a Lambda Edge origin response function there, and we also have a CloudFront functions viewer request associated to that specific behavior. Let's see how this works practically. When you create a CloudFront distribution, AWS provides you with a domain name you can use to access your origin. We will use it to access the image in our S3 bucket. So I've already requested. If I come here, we have the image. There is no query string D in the request. So the Lambda Edge origin response will not resize the image. It just return the default image we have in our S3 bucket. So if we run and this default image, the size is more than 200 KBs, and it is image. The content type is image JPEG. Let's request, for example, D equals 200 times 200 and see how this will work. You see, now we have a smaller image. The size of this image or the content length is just 7 KBs, and the content type now is image JPEG, WebP. It is no longer image JPEG. So AWS Lambda Edge, the function we have, took a look at the accept header and notice that we have image WebP there. So this specific client supports image WebP, and that is why the content type is image WebP, and we have only, and the size is way lower than if we request the normal image. So this significantly reduces the data transfers and improve performance. If I request maybe a larger image, let's say 500 and 500, I have a larger image and only 31 KBs, still image WebP. I can do the same using the CLI. Here we have image JPEG. I send accept header so that the Lambda Edge function can, or the CloudFront function, we know that, okay, this specific client have the image JPEG accept header, and we request 600, 600. So let's see, you see here we have an image, the content length is 46 KBs, and we have image JPEG. Let's go in our S3 buckets and try to refresh this. You see that we have new folders in our S3 bucket. These folders were created by our Lambda Edge origin response functions, and in each of these folders we have some images or some folders. In that S3 bucket, you have the image logo, and you have the image here as well. Lambda Edge provide CloudWatch logs and CloudWatch metrics to help you, for example, know how your functions work. With CloudFront functions, all the logs are safe in US East 1 region. If you go in the log groups, AWS CloudFront functions, and the name of your function, you will see all the logs related to your CloudFront functions. Here, for example, we have a query parameter URI to request. It is exactly what we had, right, when we were when we were testing the function. And here, the console.log, you must have console.log to be able to log request in CloudWatch logs. So this concludes the demo. It is a very quick and short demo. If you want more information, refer to this page, to this blog post. For more information about CloudFront functions and Lambda Edge, when to use one, when to use the other, the use cases and all that, refer to this page in our documentation. Thank you for your attention.
Thank you for watching the demo. Here are the links to some resources you can use to know more about Amazon CloudFront. You joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS training and certification networking. For networking, we offer more than 15 free digital courses from beginner to advanced levels for cloud architects, network engineers, and solution architects. Use these courses to learn how you can create AWS and hybrid IT network architecture at scale. Validate your experience with an industry-recognized certification in advanced networking and take advantage of an exam readiness course. For more information, visit aws.training/networking. Thank you for your attention, and please don't forget to fill the survey. Thank you.